discuss about how to convert the straight chain glucose structure into the ring form. Hello, this is Dr. Rasim Shabir and welcome here. It's very simple, very easy. You just need to know a few basic steps. So as you all know that glucose contains 6 carbons, 1, 2, 3, 4, 5, and 6. So what you need to know here is that there is a functional group, which is the aldehyde group. So you need to carry the oxygen of this functional group. By that I mean this oxygen, and you need to join this with the second last carbon in this chain. And the second last carbon is the 5th carbon. So if you join these two things, then whatever you see within these two arrows is going to be the part of the corners of the ring. Listen to me again. Whatever you see here is going to be the part of the corners of the ring. Remember that. I will apply that shortly. And then whatever is outside these two arrows, which is CS2OH, is going to be outside of the ring's corner. Alright, so let me tell you what I mean by this. Okay, so this oxygen is going to be joined by this carbon. So here is oxygen, and here is a carbon, this carbon. And you can see that this carbon is in turn attached with OH, H, and this carbon. So let's apply the same thing here. So this carbon, this is this carbon here. This carbon is in turn attached with H, OH, as well as with another carbon. You can all see here. Alright. And then this carbon is in turn attached with this carbon, one more carbon, and then one more carbon. So you have some basic idea now that how many carbons are going to be connected at the corner of the ring. So they will be 1, 2, 3, 4, and 5. So let's make the ring structure containing 5 carbons and 1 oxygen. So C, C. Here is another C. Then we have one more C here, and one C here, and then this corner is with O. So this is a ring containing how many corners? 1, 2, 3, 4, 5, 6 corners. Out of these 6 corners, 5 are being occupied by the carbons and 1 is occupied by oxygen. So I'm going to just fill out the rest of the parts of the ring. You can see that you have to attach H and OH to complete the valency of carbon, which you all know is 4. So this carbon should have 4 bonds, 1, 2, 3, and 4. Then here we will attach OH and then H. Then similar thing, very similar thing. I'm not doing anything special. I'm just attaching H and OHs with the carbons to complete the valency. Now this carbon will be bound to 1H, and then on top this will be CH and OH. But you have to remember that there is one carbon which is going to be out of the corners of this ring. This last thing is important. So this CH2OH is basically here. This is going to be out of the ring. So the bottom line is, what I'm trying to explain here is, just attach this oxygen of functional group with the second last carbon, and whatever is within these two arrows is going to be at the corners of the ring. Here it is at the corner of the ring. And then whatever is outside these two arrows is going to be out of the corners of the rings. I hope you learned something. What if you try the same thing with the ribose? It's going to be pretty similar, except that ribose has 5 carbons. So C5H10O5. So make the straight chain structure of ribose and then convert that into the ring form. Why don't you do that and take a picture and attach that in the comments below. Let me know if you have any questions.